This paper slip video is by Jonathan Manuel, Mercedes Patterson, and Anna Kohler.
Chapter 11, Section 8, Question 11, The Medici Family Crest.
For nearly 400 years, the Medici family of Florence, Italy, was successful in farming, banking, and the silk and wool trades. Additionally, the family gave so much support to artists that the Medici name has become synonymous with patrons of the arts. The crest of the Medici family features 6 golden hemispheres. The use of 3 gold spheres to symbolize pawn shops is believed to have originated from the Medici crest. Adam A. Hamada, sculptor and student of the Italian Renaissance, has designed a statue in honor of the Medici. The statue features the Medici crest with the 6 hemispheres, as well as the 3 gold spheres of the pawn shop. Adam needs to determine whether the cost of electroplating the 6 hemispheres, diameter 6 centimeters, and the 3 pawn shop spheres, diameter 8 centimeters, in gold will stay under his budget of $150. The electroplating shop tells him to expect to pay about 14 cents per centimeter squared to electroplate the figures. Will he be able to stay under budget? If not, what diameter pawn shop spheres should he make to stay under budget?
Since the formula for surface area for a hemisphere is 2 pi r squared, and the radius for our hemispheres is 3, and we have 6 of them, you have 3 times 2 pi 3 squared plus the formula for a sphere, for the surface area of a sphere is 4 pi r squared. Our radius for our sphere is 4, and there are 3 of them. When you square the 3, you have 9, to give you 6 times 2 pi 9 plus 3 times 4 pi 16. You have the 16 from squaring the 4. Then you multiply the 2 and the 9 to get 18, and you multiply the 4 and the 6 to get 64. 6 times 18 and 3 times 64 gives you 108 pi plus 192 pi.
Which that will give you 300 pi. And then you multiply the 300 pi by 0.14, which would give you about 131.947.
So your grand total in dollars and cents is $131.95. You subtract that from 150, which is Adam's budget, and you get $18.05.
Adam will be under budget by $18.05, so he is good. Chapter 11, Section 9. Question 2. Authentic or fake Incan amulet?
An amulet was recently uncovered high in the Andes by Seymour Hills, noted avenger and archaeologist. Professor Hills must do some calculations to determine if the charm is an authentic Incan relic or a modern tourist trinket. If the volume of the regular hexagonal ring is equal to the volume of the regular hexagonal hole in its center, then it is authentic. If not, then it is a modern imitation. From the dimensions shown in the figure, determine whether the amulet is a modern fake or an authentic Incan relic.
Find the area of the trapezoidal prism first. Your height of your entire hexagonal prism is 2, but you're trying to find the area of just the trapezoid. So your base 1 is 4, base 2 is 6, and we have to find your height. To find the height, you're going to draw a line from the top to the bottom. You're going to make a perpendicular bisector. So you have 90 degrees there, and since this angle is 120 in a regular hexagon, this line will bisect this angle, giving you 60, giving you a 30, 60, 90 triangle. Since we know this is 1, from subtracting the 4 from the 6 and then dividing it by 2, you know that this is 2 because you have a, 2a, and a square root of 3. This means that the height of your trapezoid is square root of 3.
So your formula would be 6 multiplied by 1/2 by 4 plus 6 by the square root of 3 by 2. So to simplify it down, 4 plus 6 would equal 10. So it would be 6 times 1/2 times 10, square root of 3 times 2, which you would want to multiply 1/2 and 10, which would leave you with 5, and then you would multiply the 5 and the 2, which would leave you with 10. And so when you multiply 6 by 10 by the square root of 3, that will leave you with 60 square root of 3.
Now you have to find the area of the hexagon in the middle. You have your side and your number of the sides, but you don't have your apothem. To find the apothem, you're going to draw an angle bisector down to the bottom line of your equilateral triangle that you've drawn. This will give you 2 as one side of your 30, 60, 90 triangle. According to the 30, 60, 90 triangle, since that is 2, that'll be 4 because that's 2a, which will give you 2 square root of 3 because that is a square root of 3. So your apothem is 2 square root of 3.
Now you would want to find the volume of the smaller hexagonal prism within the larger hexagonal prism. So you do 1/2 apothem times side times the number of sides times the height of the entire prism, which would give you 1/2 times 2 square root 3 times 4 times 6, and you multiply all of that by 2. And then that would give you 1 square root of 3 times 24 times 2. So you would multiply the 1 and the 24, which would give you 24 square root of 3 multiplied by 2, which 2 times 24 times square root of 3 would give you 48 square root of 3.
48 square root of 3 and 60 square root of 3 are not equal, so this amulet is a modern fake.